we have to solve this equation by MATLAB code. So initial guesses for the given equation is x1 equals to 0.6 and x2 equals to 1 for 3 numbers of iteration. So we open the MATLAB. In that we have to type a or we have to generate a code. So that code should be generated in editor. So go to here and click. So an editor box is open. So this one is the editor box. In this we have to type a problem, our code. So for that condition we have to assume two initial guesses. Initial guesses given are x1 equals to 0.6, x2 is equals to 1. So we have to assume it. So x1 is equals to is input in bracket, enter value of x1, complete. The message is completed, then inverted comma close that message, suppress with a semicolon. And similarly for the x2, that is we have to define x2. These are the user inputs, so that's why we define it. So same for x2. So this is x2 and this one is for x2. Now first that we have to define a function. So function is given as that we suppose define the function name as f, which is equals to inline in bracket, inverted comma, close that bracket, and with a semicolon, that is cos of x minus x. So that is the complete define of function. Now we have to find out, we have to use this function that our initial assumed guesses are correct or not. That means we have to check a convergence criteria. So convergence criteria we require, that is function value for x1 and function value for y1. So we define new function, that is new value y1 is equals to f of x1 and y2 is equals to f of x2. So these two values are defined. Then the convergence criteria by using the while loop. So while y1 into y2 is greater than 0, that means we required less than 0, that is that value should be negative. But if that value is greater than 0, that means you have to redefine the values of x1 and x2. So again we have to define x1 and x2 as the same. So we define it. So suppose then the message will be displayed that enter the value of x1 again. That means we identify that we have to enter the values of x1 and x2 again. Okay. Then we have to reuse this. So again we have to find out y1 and y2, because after defining x1 and x2 here again, so y1 and y2 should be get updated. So new y1 and y2, and this y1 and y2 are again we are going to use to check out this convergence criteria, and this loop should be end by using such a condition. While is end at this. So next we have to find out, we have to perform iterations. So for I is equals to 1 is to n, value of x3, that is the root of equation, is equals to in bracket x2 into y1 minus x1 into y2 divided by y1 minus y2. So condition is defined, and then we have to find out f of x3. So y3 is equals to f of x3. So we define f of x3. Then again for number of iterations we have to check the condition. That means we have to update it, we have to use x3 for next iteration. So the next is if condition, that is if y1 into y3 is less than 0, then this is a correct condition. So we have value of x1, that is y1 is correct, so we have to reuse y3 as a x2. So x2 is equals to x3 and y2 is equals to new x2, function of new x2 is equals to function of x2. Complete. Else if this condition is not satisfied, that is this condition is not satisfied, means y1 into y2 into y3 is satisfied, so x1 is equals to x3 and y1 is equals to y3. So this is total. So for one if the end, and for loop the end is given, so it shows highlighted and print x3. So this is a complete program. Now save this program in our working directory where we want to save. So save as, suppose we save on desktop and the name is rf suppose, save it. Now run that program. It shows that we have to change the current working directory, so yes, change. So some error is open, that is unbalanced or unexpected bracket at line number 5. So here the balance bracket is remaining, so again we updated it and again run that program. In line number 10 again, that is we are copying, so run. Now x1 value is 0.6, x2 value is 1, number of iterations, that is number of iterations is again remaining, so n is equals to input number of iteration is equals to, so this should be clear. Again run. So x1 is 0.6, 1, 3. So value of x3 is 0.7391. So in this way we find out the root of given equation cos of x minus x equals to 0 for Regula Flasi method, again for iteration criteria and for given initial guesses.